So here we go, example 1. Part E says, state the area of a circle in terms of A and R. What is the area of a circle? Area equals pi r squared. And part B says, find the rate of change of the area A of a circle with respect to its radius r. So I am finding the rate of change, which is the derivative. I want A prime. How do I find the derivative of pi r squared? What's the derivative of pi r squared? 2 pi r. And you can see that if we do the product rule, for example, between pi and r squared, I have pi times the derivative of r squared, which is 2r. And then the second half of the product rule is just 0 because pi is a constant. So I get A prime is equal to 2 pi r. And part C says, evaluate the rate of change of A at r is equal to 5 and r is equal to 10. So I want A prime of 5. So I am going to take 5 and plug it into my derivative here. So that would give me 10 pi. And then they also asked me for A prime of 10. So I'm going to take 10 and plug it in and get 20 pi. So part D, if R is measured in inches and A is measured in square inches, what units would be appropriate for dAdr? First of all, what is this? What is dAdr? It stands for the derivative with respect to R. And so let's look at this. It's dA over dr. And so my area, what are the units for my area? It's measured in inches squared. And what are the units for my radius? It would just be inches. So I have inches squared over inches, which is a little weird to think about, but here's what that means. It's a little weird at first glance. Right? But that is saying if I have a circle and I increase the radius of the circle, what happens to the area? It increases in square inches. Okay, same thing if I have a circle and I decrease the radius, then my area will also decrease in square inches. Okay, so example 2, what I want to do is kind of go through these and make sure that we understand conceptually what we are talking about. So example 2, it says the number of gallons of water in a tank, T minutes after the tank has started to drain, is QT equals 200 times 30 minus T, parentheses squared. And so let's think about QT for a second. Maybe you like racetrack, I don't know. But let's think about QT. You can at least smile. You know, I know we have a mask on, but I mean, I could throw out a little unexpected pun there, and you could at least say, "Okay, that was a dad joke, Newhouse. Come on." What is QT? Is it on amount? Is it a rate? Or is it a rate of change of the rate? Because it helps me to think about these in terms of physics. Is it a position? Is it a velocity? Or is it an acceleration? Amount, rate, or acceleration. Read the problem. It says the number of gallons of water in a tank. So what is QT measuring? How much water is in the tank? And that is an amount. So this is like a position equation. It's not measuring distance in the context of this problem. It's measuring the amount of gallons in the tank. But this is like a position equation. So part A says, what would dq over dt of 5 compute? Include units in your answer. Well, what is dq dt? Is it, what's it like? It's the derivative of q of t. So this is a rate. It's like a velocity. And let's describe it. dq of dt of 5. At 5 minutes, the water is draining at this rate and now I'm going to put my units on there in, what are my units? Q is measured in gallons, amount of water. Time in this instance is measured in minutes. So at 5 minutes, the water is draining at this rate in gallons per minute. At what rate? Well, I would need to take the derivative of my equation. I don't need to do that here because they didn't ask me for that. I'm just describing what this is computing, but I could expand the 30 minus t squared and distribute the 200 and get an equation and then take the derivative of that. Okay, and so part B says, what would Q of 7 minus Q of 4 over 7 minus 4 compute? Include units in your answer. So what does this look like? It's an average velocity. Why is it an average velocity? Because it is a change in, what's in the numerator? What's changing? The position over a change in time, which is an average velocity. Look at the units, right? Position over time gives me velocity. So let's write out what this is computing. It is an average rate of change of water draining in gallons per minute when? From t is equal to 4 to t equals 7. And that's all they asked me to do, right, is describe what that is computing. So I'm going to pause there for just a second. Any questions over anything that we've done so far? Okay, for the next example, you will need a calculator. And example 3 says the rate of change in kilometers per hour of the altitude of a hot air balloon is given by R of t is equal to t cubed minus 4t squared plus 6 for time between 0 and 4, where t is measured in hours. So this is like a what? It's a rate of change. It's a rate. So this is like a velocity. You can also notice that from the units. It's kilometers per hour. So part A says use a calculator to find the values of t for t between 0 and 4 for when the altitude of the balloon is decreasing. So let's do that for me, please. Take your calculator and graph the rates. And let's find where the rate is decreasing. You might want to change your window settings from 0 to 4. You don't have negative time. It's going to look something like that. And so how would I find where the rate is decreasing? It's whenever my rate is negative. And so this is a graph of R of t. Therefore, I'm going to look at when R of t is below the x-axis. So I need to find these zeros, this point and this point. So go ahead and do that for me. And I'm going to say R of t is less than 0 on these intervals. Okay, this one's 1.572. And this one over here was like 3.514. So I got 1.572, 3.514. Is when the balloon is decreasing.
How do you find on the calculator?
You find the zeros, hit second trace,
Second trace.
and then go to 0. And then move the little spider thingy on the left side of where you want to find it, and then on the right side, and then hit enter. I can show you in just a second. Okay. Part B says find the value of R prime of 2, give units in your answer. So if I'm taking the derivative of the rate, that's going to be like an acceleration. So I'm going to take the derivative of my equation. Derivative of t cubed minus 4t squared plus 6 is 3t squared minus 8t. And then I'm going to evaluate at 2. So R prime of 2. I plug in 2 for t. And let's see, that will give me 12 minus 16, which is negative 4. And then I need my units, okay? And again, this is like an acceleration because I'm taking the derivative of the rate. So the units for my velocity were kilometers per hour. So this would need to be kilometers per hour squared. Okay? We all good? One last example here on the first page, multiple choice. The temperature T in degrees Fahrenheit of a cold pizza placed in a hot oven is given by T is equal to F of T, where T is the time in minutes since the pizza, I believe it should say, was taken out of the oven because it's cooling. And we want to choose the best interpretation of T prime of 6. So again, let me work through this and I'll word through my thought process. What is T in this instance? Is it an amount? Is it a rate? Is it a rate of change of the rate? An acceleration. What's T measuring? The temperature in degrees Fahrenheit. So this is an amount, therefore this is like a position equation. They asked me choose the best interpretation of T prime of 6. So my answer needs to be, it needs to be like a velocity or a rate. So let me read through the answer choices. The average number of degrees the pizza cooled after 6 minutes. That one's out. It's not an average. We're just finding the derivative, correct? Part B, the rate of change, okay, in degrees per minute, looks good. Okay, the pizza is cooling at t is equal to 6 minutes. Well, that's going to be it, right? That's my answer. But let me go through the other two. The total number of degrees the pizza has cooled. No, we're not finding the total there. The rate of change, okay, in degrees per minute per minute. So that per minute is giving me the acceleration. So that one's out. So B has to be the correct answer. I see this question fairly often on the AP exam, okay? So it's important that you understand that. Questions or anything on the first page?
What is an average rate of change?
Then that would not be the derivative. It would be the slope of the secant line between 2 points or 2 time periods.
Yeah.
All right, I think we need a little calculus stretch break. Come on, we look a little dead. Let's go, stand up. Wave your arms in the air like you don't care.
You should remember to do this. Calculation.
Yes, let me finish first and then I'll show you. Okay. All right, well, I really should count how many free response questions we do before the AP exam. I mean, it's got to be like 100 or so. We do a lot. So let me talk about normal AP exam procedures, okay? Assuming that you all will take a normal exam. There are 6 free response questions. You get approximately 15 minutes per question. 4 of the questions are non-calculator, 2 of them are calculator. Each question is worth 9 points. If you want to pass, you need to be above the mean. Okay, which is not too hard to do. There's a lot of unprepared people out there that leave the question blank or something like that. So if you're above the mean for every question, you will pass. All right, so let's look at an example. This is an actual question from a previous exam. It says, Karen rides her bicycle along a straight road from home to school, starting at home at time t is equal to 0 minutes and arriving at school at time t is equal to 12 minutes. During the time interval from 0 to 12, her velocity, v of t, so this is a velocity graph, in miles per minute, is modeled by the piecewise linear function whose graph is shown above. Okay, so I have a velocity graph. It's measured in miles per minute. Part A says, find the acceleration of Karen's bicycle at time t is equal to 7.5 minutes and indicate units of measure. So I'm going to go out here to 7.5 and put me a little dot, and I need to find the acceleration. The acceleration is the what? It is the derivative of the velocity, which I do not have equation in this instance. So here I have to find the slope. So I'm going to use this point and this point on my graph and find the slope. Pretty easy. College Board is giving away points, so don't miss slope questions. I want, let me start over here. I want A of 7.5, which is equal to the derivative of the velocity of 7.5, which is the slope. So I need V of 8 minus V of 7 over 8 minus 7. Just the slope of the line segment. So what is V of 8? V of 8 is right there. It's going to be 0.2. V of 7 is right there. So it's going to be 0.3. So I've got 0.2 minus 0.3 over 1. And 0.2 minus 0.3, it's got to be negative, right? Look at the graph. Don't make that easy mistake. This is negative 0.1. And then don't forget to include units of measure. This is an acceleration. So my units would be miles per minute squared. So I told you for each question, each free response question is worth 9 points. This section was worth 2. 1 for the correct answer, 1 for the units. Most times the mean's probably somewhere around 4. So you're probably halfway there just after this. All right, part B. Using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of e of t dt in terms of Karen's trip. A preview of coming attractions. Let's get that. Part C. Shortly after leaving home, disaster strikes. Karen realizes she left her calculus homework at home. And the supreme calculus dictator is going to put a 0 in, and UIL grade checks tomorrow, and she's going to fail. And her coach is going to make her run, I don't know, like 500 suicides or something. So she returns home to get her calculus homework. At what time does she turn around to go back home? Give a reason for your answer. So look at the graph. At what time did she go back? I hear 2 seconds. 2 seconds. 2 minutes. Get your units right, Newhouse. Why do we say 2 minutes? How do we know she changes direction? Because this is a velocity graph, and velocity changes from positive to negative at 2. So you are correct. Okay. She returns home. Let me scroll. Stop that. She returns home. At t equals 2 because velocity changes from positive to negative. Part E. What is Karen's total distance traveled after 4 minutes has elapsed? You do not need to know this right now, but come on, physics people. How do we find total distance? It's the of a velocity graph. So area under the curve. So I have a little triangle here. The base is 2, the height is 0.2. So that gives me an area of 0.2. And this is equivalent to this. It's just below the x-axis. So my total distance traveled is going to be 0.4 miles. This is the area under the curve. Of a velocity graph. That's how we get total distance, which we will get to. Part F. What is Karen's displacement after 4 minutes has elapsed? Not the same as total distance in this instance. What is displacement again? Where you are relative to where you started, and her displacement after 4 is 0. Why is it 0? She got back home, so she's where she started. How do we know she's at home at 4? Well, that just means the velocity is 0. How do we know she's back home after 4? Because this area is equivalent to this area of the triangles there. So yes, her displacement is 0 after 4 minutes. What was Karen doing from the 4th minute to the 5th minute? Well, what's her velocity? Her velocity is 0 during this minute. So we assume that she was getting her calculus homework, but I don't know. I mean, she could have been making a breakfast burrito or something. But we know, we can say definitively that she was not riding her bike. So velocity equals 0. So she was not riding her bike. And finally, part H. Is Karen speeding up or slowing down at t is equal to 7.5 seconds? And why? So for speeding up and slowing down, there are certain things that they are looking for in the AP exam. So to get full credit, you've got to include all of these parts. Is my velocity positive or negative at 7.5? Positive. Is my acceleration positive or negative? Negative. Slope is negative. So here's what you need to say. Velocity is positive. Acceleration is negative. Therefore, she was slowing down because I have opposite signs for velocity and acceleration, but you also need to include the time. And yes, it says the time right there, but she was slowing down at t is equal to 7.5. Now I'm getting me full credit. I was generous. If you told me something about the velocity and the acceleration and got that right, and got the slowing down or speeding up right, I should have given you credit. Moving forward, however, my generosity will cease, and I will revert to my old ways of being mean and dictatorial. All right, well.